I'm going to tell about our experience experimenting and testing various types of setups. We were running Spark on different environments, on different schedulers. As you know, it supports multiple schedulers like Mesos, Kubernetes, and Yarn, and also standalone mode. So we were basically curious which one performs better, because for our workloads and for our environment, we are constrained with the resources. We are not able, for this part of our setup, where we were not able to use any sort of cloud. So our resources were constrained, and we wanted to squeeze the most of performance, most possible performance out of the setup. So we performed several tests on various setups, which I'm going to go through in a moment. And also I'm going to tell you what relative results we received. And generally, I think in 90% of the cases, we are going to advocate for one setup in this test. So as I told you, the objective was to choose an on-premise infrastructure management platform for Spark. So our product is deployed inside mobile operators' data centers, so there's no possibility to dynamically add any sort of nodes. And and Yarn also doesn't support that really easily as well. So let's talk about compute resources in a moment. I've separated the measurements into two, let's say, categories: the compute part and the memory part, as they are like two distinct performance factors for Spark. So for Yarn model, as you know, it uses its own scheduler mechanism, where it has two critical components called resource manager and node manager that decide where your application should be deployed and which resource. It is kind of a little bit older approach, because it was designed back in early 2000s, primarily to run MapReduce sort of workloads, like very heavily, like batch processing, Java related. So this was the first thing that we tried, actually, and this was what we had more experience with, and we did some measurements with it. The good thing about it is that it's very mature. It may not seem very like functional and very good and very convenient, but it's very mature at the end of the day, especially working with Spark, because Spark, it was the first class support citizen for Spark for a couple of years when it was newly released. And it also works. It's also very native to all the Hadoop ecosystem, where HDFS also is one of the components. The downside, it's very old, and it's very cumbersome and inconvenient to configure. It's primarily written for MapReduce, although in the recent versions, it allows also to run containerized jobs like Docker containers. I'm not talking about the Yarn containers, which it also has, but I'm talking about actual, let's say, Docker containers. Its resource management this is the most different part from Kubernetes. Its resource management is different. I wouldn't say it's bad, to be honest, because it supports a lot of stuff like group resource management for groups. It was designed primarily for enterprise customers to always have like sufficient load for their sufficient resources for their workloads. But its management is really complex. You need to really know what you're doing with it and not to mess it up. Running Spark jobs on Yarn also introduces a lot of Hadoop dependency issues. I think every single one of us who ever tried to run it came across that kind of issues related to Hadoop class path, etc. It's really not an easy experience to work with Yarn. But at the end of the day, it does what it promises. Let's go to the second model of the comparison. It's the Kubernetes model. It was built from ground up to run Docker, not Docker, but containerized workloads, and Docker container is one of the examples. Spark also supports running it inside the Kubernetes cluster. How it happens is that it first launches the driver as a pod, and then the driver launches the rest of the workers as other pods. They're very different. there is no like 100% solution that's right or wrong, but in most of the cases, I think the Kubernetes is right, and the reason behind is not that much the performance. I'll go through the details now. What's the pros of running it on Kubernetes? That it's containerization, easy resource control. Actually, also these all benefits are coming from the containerization. This is not very specific to any Spark issues, but all this comes with containerization benefits, most of the part. And the big plus here is the cloud native like origins of Kubernetes. So if you're running Spark on cloud, and if you're not using any sort of managed services, you should not go for Yarn. That's like 99% of the cases. You should go with Kubernetes. From the downside, it's kind of inconvenient to use for analytics type of things. Let's say you want to install some sort of a notebook on it. With Kubernetes, it's possible to do that. We did that, but it introduces additional challenges. Yeah, and also it lacks storage out of the box. Well, Yarn doesn't have storage as well, but Hadoop has the storage called HDFS. But you need to think about some sort of storage to host all your data if you run your Spark workloads on Kubernetes. Let's talk about storage a little bit. So we compared two storage models in our test. One of them is the Hadoop native storage engine called HDFS. It consists of two important entities, name node and data nodes. It was the first class support citizen for Spark for many years, and it offers highly scalable data storage and high performance data retrieval and write capabilities. And this is what Hadoop was designed to work best with. But we did the like cross test as well. I will go through that in a minute. The second storage engine that we used was Minio, or Minio. I think it's Minio. It is an S3 compatible object storage. So it is designed to be deployed on top of a Kubernetes cluster, but you also need to have a block storage for it to be deployed on. So you cannot deploy it on just the Kubernetes itself. So it needs to have some sort of a hard drive, let's say, that it should store its actual data on. So that block storage itself introduces an additional layer of performance bottleneck, if it can be called so, because it also introduces some additional workload that needs to be performed before an object is stored on a Minio as a Minio entity and as a Minio object. Yeah. So how we did the test is we ran. Well, first of all, let's talk about hardware. We took 12 machines. We divided them into two clusters, one for compute and the other one for storage. Here, an important question is the data locality. From the beginning, we decided not to consider the data locality to be able to measure the full performance of the storage engine and the processing engine alone. So also for our specific jobs, the data locality was not helping too much. So those are like two. We divided this into two separate clusters. Each had 6 nodes, 12 cores, and 128 gigabytes of RAM and 2 terabytes of SSD. And the other cluster had the storage with the same configuration, but it was holding the storage. So Minio storage, again running on Kubernetes, and underneath there was a Longhorn as a bucket block storage, and HDFS. So we ran the test on all possible combinations. So MapReduce using Minio, I'll call it Minio, whatever, and Kubernetes using HDFS and Minio. So this is what, as you can see also by the logos, this is what they are like traditionally built for. And to our surprise, the difference between these workloads was really like minuscule, approximately like up to 10% of difference. These are the like relative results of the performance test. I can tell what we were doing. We were basically performing lots of random Spark, not random, but they're doing all the same, but they're doing filterings, push down predicates, aggregations, yeah, and also various sorts of read and write workloads. And all the tests were performed like 50, 20, from 10, 20 to 50 times to get the consistent results out of each like pair of measurement. And we took like Kubernetes and Minio as the baseline for the performance. So if it took 1 minute here, it took 0.98 minute there. So you can see the results. Actually, MapReduce and HDFS performed the best. But with all that said, it's really arguable which one you should go for. In most of the cases, actually, this one is preferred, and we went for this one. For the reasons that it's much more easier to manage, and it's also cloud native. One day, if you decide to switch to on-premise to cloud, it's really no hassle to do that. It's really easy to do. Yeah, basically, this was it for the performance comparison. And I've left a lot of numbers behind. So there are also other important factors such as container startup time for some workloads, stream processing. We actually, to be honest, we didn't manage to do full like stream testing for this reason, because it would just have been like a scientific interest. We were after just like finding what we really need, and we didn't need any streaming sort of workload, so we didn't test it. But I assume that the results will be approximately the same, because the workload we were running on our cluster contained a lot of like operations using like big batches of data, small batches of data. So it should have some overall like comprehensive understanding. So it should give some overall comprehensive understanding about how they perform. Yeah, but after all, we went with Kubernetes plus Minio because the performance difference was really small, but the maintenance cost was really huge. That's kind of it. Kind of a high-level overview of what we did. If you're interested, I can find and send you the actual results, like in numbers, in seconds, and what data we used and what queries, what workload we had in the script that was running the test. Yeah, if you want like specific numbers. But mostly, this was it. Yeah, I can answer your question.
Can you say a few words about what task are you solving?
Yeah. So it was, I think, about 10 or 15 billion rows, each containing 5 columns, and we were doing. There were multiple operations and inside one script, and that one script was running for like 50 times for one like number like this. So it was basically filtering like where sort of operations, shuffling operations, joins. There were like operations which were involving predicate push down to be able to see how it understands that, how that performs. Aggregations, yeah, mostly that kind of operations. We didn't use any sort of like Spark ML capabilities to learn some model or to do some sort of inference, because that was not our goal. But yeah, those were the operations in the script. No, this is the conference about data. It's called Data Fest. Yeah, we were using data, not the machine. I'm not a machine learning like specialist, to be honest. I'm an engineer. No, there were 12 servers. Yeah, there were 12 servers. This is not a 12 core CPU. This is 12 servers, and we divide into 2 groups of 6 12 core servers and 6 12 core servers. Yeah.
This is local setup. It's like in your own lab, or do you use some kind of public cloud, something like this?
This is really in between. We don't use public cloud. That lab is not ours. That lab belonged to a mobile operator where the tests were performed. But I think it's also possible to access that environment as a service for them.
And what versions of Spark were you testing?
2.31.
I'm guessing same version in Kubernetes than in Hadoop.
You mean the Hadoop version?
The Spark version on on the Spark cluster?
Yes, it was the same. It was the same. It was the same. Yeah.
Since you didn't use public cloud, probably you didn't go over it, but did you consider
We use it.
AWS solution for Hadoop?
We use public cloud for different parts of our platforms. We use it, but for this specific part of our product, we were constrained because we work with data that cannot be taken out of mobile operators' premises. We cannot use any public cloud.
No, I was wondering because the EMR from AWS actually relieves some of the costs that you have with.
Of course. We use Google Cloud. We don't use AWS, but we use Google Cloud, and I think use most of its potential for other type of like analytics, for example. We use Databricks with all the Google specific stuff. So far, we're using HDFS for I think 9 years maybe, and so far we didn't have any, let's say, very major reliability issues with HDFS. We had issues related to we had some data loss as well, but those were not related to HDFS specific, let's say, problems. Most of the times that was our fault. So with Minio, we're like relatively new to it. Just use it for like 2 years, maybe a year and a half, starting from the point that we discovered it, let's say. So far, so good. It's actually easier to manage, what I can say. But with reliability perspective, we didn't have any issues with it yet. I cannot point out any specific issue that I'm aware of. Yeah.
For the Spark cluster in Kubernetes, do you use Helm or something like this, or it's just
No. We just deployed it. We just deployed it using Spark Submit, and everything worked well. We use Helm, but not with this setup.
Did you consider Ceph instead of Minio?
Ceph?
Ceph.
What was that? Block storage, you mean?
Yeah.
Yeah. No. Yes, we considered, but not instead of Minio. We considered it as a backend for Minio. So, but we've set it up. It's like a masterpiece of engineering, I think, because it contains so many options that others lack. But for us, it was an overkill for this type of operation. So we switched to Longhorn, which was easier to set up as a block storage. And yeah, and it talked to Minio well, so we stuck with it. But that's something that we can consider in the future. Maybe it performs much better than Longhorn, but we didn't perform any tests with it, but we considered it. Any more questions? We didn't use MapReduce. This is it should be Yarn here actually in the logo. We didn't use MapReduce. We used MapReduce back in 2014, but we immediately, when Spark came out, we immediately replaced it with, like, tried to replace it with Spark. Yeah, it should be Yarn in the logo. Actually, it was Yarn in the previous logo, so yeah. Yarn was primarily designed for MapReduce. We used it, but of course, if you compare the performance of MapReduce and Spark, there is a difference, but there is a much bigger difference in the actual cost of development using MapReduce and using Spark. It was a synthetic data. We didn't use real data for this because we needed to have some precise like size of data with a different how do you call variance in the columns, etc. So it was a generated data. It was not real data. It contained mostly some sort of string, int type of columns, 5 columns there. So there is no meaning inside that data. Yeah, of course, yeah. Because we needed to have some different variance in the columns, and why we should find some 10 billion records from somewhere where we can generate it.
And the knowledge that you got from this, where you are going to use it?
We already use it. We use this knowledge. We chosen at that time, about a year ago, I think, no, a little bit less, we decided to switch from this setup to this setup. Although this is slightly more performant, but we switched to this one because of the cost of the operations. Yes, it is used right now on our product. Our product, I think that's kind of out of the scope of the presentation, and we can talk about it. Yeah, I can tell what it does. Basically, our software, the most complex part of it, let's say, is deployed inside mobile operators' premises, and it analyzes the information about subscribers, not any sort of phone numbers, password, nothing like that, just the traffic, and it gains some information about what they're interested in, and then that information, without being taken away from mobile operator, that's the important part, is being used for targeted advertising, just like how Google Ads works or Facebook Ads works. And the advertisement is being shown in the websites, in the apps that they're browsing, they're using. Yeah, so that's what it does after end of the day.
I have a question. Do you
Sure.
have any estimates how much the maintenance decreased when you changed from the Hadoop to the menu? I mean, it's
Yes.
several percent or tens of percent or hundreds of percent?
We had one person complaining, I think 3 times less than the same person complaining with Kubernetes and Minio. That's the difference. And also, when we have some sort of like alerts on our monitoring, those happen much less than with HDFS and Yarn. We can call it a day. Usually this doesn't require that much operations. Only in case it breaks, then a special ticket is being requested, some access is being granted for us to be able to investigate the problem. But generally, no one is like actively looking after this. But we maintain it.
In case of the failure of something, it's you going to the logs, or you provide this kind of logs to the people actually sending the job?
It's kind of, I don't understand who is you and who is other people.
Like from what I understand, you are managing the cluster, keeping it running, and some other people is sending the Spark submits to this cluster, right?
It's automated.
Okay.
There's an Airflow that...
something fails,
Uh-huh.
The logs are available in Airflow for everyone.
Not for everyone, no. With logs, we're very attentive, so we don't send logs to any sort of like we also don't send logs outside of mobile operators' premises. It's very hard to control logs. It's a big problem we were thinking about, but logs also themselves can contain sometimes some private information. Although all the private information, let's say, is being anonymized, we keep the promise, so we never also take out logs outside of the premises. We just have some sort of heartbeat indicators, just Boolean flags or numbers that indicate some problems. Yeah, and we see the problem, then we go and check the logs inside the premises, so it's secure. The security and privacy part is like top priority for us. Thank you too.